So now we'll do a full simplex method problem. The first step is to define our slack variables. So we'll say that S1, which is related to the first functional constraint, is the right-hand side minus the left-hand side. And S sub 2 is related to the second functional constraint. And if we were to put these slack variables back in, we would get equations. The gaps are intentional. And then also, if we brought everything over to the z side in the objective function, we would get negative 2x1 minus 2x2 plus z equals 0. Okay, that's the information that we need. So let's set up the the initial simplex tableau technically. So BV, basic variable, x's followed by s's, followed by z, followed by the right-hand side. The first two rows in this case will be the objective functions. And, the first two rows in this case will be the functional constraints, and the last row is always the objective function. I'm a duplicating because I know what's coming. I think we have 2 pivots for this one, so this should be sufficient here. Okay, it's very hard to know how many pivots you have. I'm just trying to save time on my end for less writing. So the first equation, x1 plus 3x2 plus s1 equals 6, becomes 1, 3, 1. There are no s sub 2's, there are no z's, and the right-hand side is 6. Oh, I forgot my vertical line. Put it. To do this manually. So much work. The next one, x sub 1 plus s sub 2 equals 3, becomes 1, 0, 0, 1, 0, 3. And the last row is the objective function row, looking at the top there, negative 2, no s sub 1's, no s sub 2's, 1 z, right-hand side is 0. And as stated, we start off with the basic variables being our slacks, and this was always going to be z. That should never change. Okay, to determine the pivot column, which is the first thing you do to find the pivot element, is you find the most negative number in the objective function row. Well, we have a tie. We have 2 negative 2's downstairs. So the rule is you take the one on the left. So this will be our pivot column. Now you take the positive entries of the pivot column and divide them into the right-hand side. So this one, I don't know why that's a highlighter. This one into 6 makes 6 over 1, which is 6. And this one into 3 makes 3 over 1, which is 3. Since 3, that ratio, is smaller than 6, then let me undo those things because I don't want them in the way. Click, 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 click. Then we take the, I'll use this color because it's obnoxious. This is our pivot row, which makes this, the intersection, our pivot column. Okay. So to pivot means to turn the pivot element into a 1 and everything else in that column into a 0. Well, the pivot element is already a 1. So only using that circled 1 can we make everything else a 0. You can't use anything else. So we said negative row 2 plus row 1 becomes row 1. And 2 row 2 plus row 3 becomes row 3. That would complete the pivot. All right. Put all of that into your calculator. You should be extremely comfortable with your calculator by now. So I'm not going to show you the calculator work anymore. If you don't know how to use the calculator, please review previous videos. Okay, hopefully you got this matrix, or this tableau I should say, off to the right now. I'm just double checking my work. Looks good. All right. Since we still have negatives in the objective function row, we repeat the process. So we have to take the most negative number in the objective function row, which is -2 yet again. And we take the positive entries of the pivot column and divide them into the right-hand side. Well, we only have one positive entry, namely that 3. Remember, 0 is not positive, so it can't be that 0. So this 3 is the pivot element. So we need to turn it into a 1, so we'll do 1/3 row 1 becomes row 1. And assuming that's a 1, we have to knock out that -2. So we'll say 2 row 1 plus row 3 makes row 3. So again, please do those two operations and come on back. Okay, so that is done. So now we can write our answer. We don't really care too much about what the s's equals, just the x's, and z in this case. So remember to read across. X1 is basic, so read across. We get x1 to be 3. X2 is basic as well. Read across. We get x of 2 to be 1. Z should always be basic. Read across. We get z to be 8. So we would say, nope, that's all you need to say.